All right, so for this example, this second example on substitution and graphing, I'm going to start with the substitution method, and I'm going to start by showing you how to solve one of these equations for y. My recommendation is if you have a system where none of the coefficients, and remember the coefficient is the number in front of the variable, if none of those coefficients is a 1, so if you don't have just a variable by itself, don't use substitution. Find a different method, either graphing or elimination, or if you're more advanced and you get into the matrices and those kind of things, choose one of those methods. Do not get bogged down in this process with substitution if none of the coefficients is a 1. But I am going to show you how to do it so you have the knowledge and you would have seen it before. But in the future, if there's a coefficient in front of all of the variables, find a different method. So we're going to start first by choosing one of our equations, and it really doesn't matter in this case which one you choose. You're going to choose one of these equations and you're going to solve for y. Or I guess you could solve for x. Let's solve for x. Alright, so let's use this second equation right here. So we're going to solve for x. So 3x, we're going to move that y to the other side so it becomes 4y minus 1. And we're going to divide by 3. So x equals 4y minus 1 over 3. And then things are going to get a little more interesting from there because we're going to be plugging in that fraction. So we're going to plug that fraction into the first equation, which was negative 3. We're going to substitute for that x as 4y minus 1 over 3 plus 7y, and that whole thing equals 13. Alright, so now we're going to deal with the negative 3 and the 3. I'm actually going to cancel those out and make that a negative 1 times 4y minus 1 plus 7y equals 13. Because 3 divided by 3 is 1, and we have to keep the negative sign so it becomes a negative 1. So we have negative 4y plus 1 plus 7y equals 13. We're going to combine like terms. Our two like terms in this example is going to be 4y and the 7y. So negative 4 plus 7 gives us 3y plus 1 equals 13. Subtract the 1 from both sides, and you have 3y equals 12. And after we divide, our y value is 4. Now that we have that first value, we're going to use that to plug back into one of the equations we have. And technically in this case, we have 3 equations. Let's see if I can get my screen to cooperate and go back to the previous slide. Alright, so we have this one. Those are our two initial equations. But we also have this one right here that we made. So we actually have 3 equations in this case. My recommendation is always to plug back into one of the original equations, just in case there was a mistake in your ability to rewrite the equation. I always say plug back into one of the originals. Alright, so I'm going to plug into the first one, so negative 3. We don't have the value for x, so let's take that part off. So negative 3x plus 7, and our y value is 4, equals 13. So negative 3x plus 28 equals 13. And we'll subtract that 28 from both sides. So negative 3x equals negative 15. And because our goal is to get x by itself, we're going to divide both sides by negative 3. because that's the coefficient in front of x right now. So x is 5. So because our y value was 4 and our x value is 5, our final ordered pair for this problem is 5, 4.